Okay, we got a Clark with the Hyundai engine, 2.4, I think, and it has a Juniper system. Problem is, it's rough when it's running. Let me start it up. Sometimes it's hard to start. Okay, now you can hear it. It's hunting. Right, as you can see, somebody already replaced this. From what I gather, they said it wouldn't even start the first time. They replaced it, and now it's running like this. See? You rev it up. It has a bit of hesitation. It's almost about to die. Alright, and so we're going to be checking that. We have the check engine light on. Alright, I already got the code from it. I will show you later how to get the code from this type of system. But the code that I got was 0087 and a 0192. Both of them pertaining to the pressure sensor for the rail. So what that we're gonna do right now is we're gonna check the response of the rail from the pressure inside of it. We know we got propane coming in, and the injectors are working, at least first of all, because it starts right. Whether they're working good or not is still a question, but again, we are starting with the rail pressure sensor because that is the code that we got. Okay, so let's do
Okay,
that.
so before we do some actual testing on the sensor, let's try to understand what the code means and how the sensor works. So two codes were present. It's 0087 and 0192. 87 is a fuel rail system pressure too low, and 0192 is the pressure sensor circuit low. Okay, for the threshold for 0087, once it reaches 1700 millibars, or the pressure drops to 1700 millibars and lower, then that DTC will be set. Now 0192 is when the voltage received by the ECM from that sensor has gone too low, then that DTC will be set. Now what's important to notice is the default strategy for the ECM when it counters a P0192. As you can see, the default is to assume a value of 1700 millibars. Now, of course, this is not going to be adequate for every scenario, and that's why I think we are having a problem at a snap throttle. When we do the snap throttle, you felt that hesitation, or sometimes it's very hard to start. Of course, it's dependent on the readings from the other sensors. But if your fuel pressure or the time of pulsing the injectors is always the same, of course, it's not going to be adequate for every scenario. Okay, so up next, we're going to be looking at the pressure sensor itself and how it works. So now this is the sensor that was used in the fuel rail. It's a Sensata sensor that incorporates a pressure sensor and also temperature sensor, but we would only be talking about the pressure sensor inside. So this sensor is a 150 psi absolute pressure transducer sensor. The output is ratio metric from zero point 0.5 to 4.5 volts. So this sensor is meant to read 0.5 at a pressure of 10 psi absolute and for 0.5 volts at a 150 psi absolute. Now, from the book for this truck, the specification is saying that it should be 1800 millibars minimum at key on. So that would roughly be 26.1 psi absolute, or the voltage using the graph, it would be approximately between 0.8 to zero point 0.9 volts at key on. And then of course at a higher RPM, it's supposed to follow the pressure sensor reading from the map sensor. So at a higher load, that voltage or that pressure reading should increase from that sensor.
Okay, so I have my channel B hooked up to the signal in from the pressure sensor. So I wanted to pin it on the computer side. So I know the pressure sensor is here, but I'd rather take it from the computer. So I know it's reaching the computer. It's easy enough to get at it anyway, it's just on the back of that panel. Alright, and then my channel A is hooked up to my map sensor, which is right here in the manifold. Right now, channel A, channel B is already set up. So I have it set up at 5 seconds per division. It's a slow signal anyway. So let's try to run this. Okay, it's running. Let's crank it. Yeah, that was rough. Okay. And we're going to key off. Okay. And stop the capture. And we're gonna clean it up a bit. I'm gonna put in our filters here just to clean it up a bit. You can see that signal a bit better. Okay, so as you can see, so at the moment the key on, let's bring down this. At the moment at key on, the reading was close to 0.96, somewhere not like 0.89, which is close to the specs in the book. But after a brief moment, it went down to about 453, which is already lower than the specs. And then once we cranked it, started it, it never went above beyond that. It does follow, but it never went to the proper readings. All right, so I know the wiring is good because it's reaching the computer. We know that the power is good, already checked it. Powers and grounds, already checked that, it's good. And so to me, it's looking like it is a pressure sensor. It's not reading right. Looking at this, if I didn't have a brand new, if nobody replaced the brand new regulator, then I would be thinking, okay, maybe the regulator is not supplying enough pressure or is not regulating properly. But at this point, I mean, it's brand new, so I'm gonna think that it is doing its job. Right, so we have fuel, but basically not enough, maybe. But I am gonna try to replace that sensor, all right, and see what happens. I don't think it's gonna be in the fuel rail. I don't think it's gonna be the injectors. Basing on how it was responding to that, to the surge of pressure, and then ultimately just dropping down right away. I mean, if it was a leak, maybe a leak in the injector or whatever that's dropping the pressure, you wouldn't see a drop that is like right away. It's steady and then drop right away at that instant. I would think more that if there was a leak somewhere here or outside, then it would be a slow drop in the readings of that sensor, and that's why I'm thinking more that it's going to be that pressure sensor that is at fault here. Okay, so got the new sensor in. That was the old sensor. All right, new sensor in. The oscilloscope is hooked up the same way. All right, it's already running. Let me stop this for a sec. So we can go back to the first one. Okay, same setup. Okay, let's try to key on first. Okay, so that's a big difference off the bat. So right now at key on, just a key on is, see, it's holding steady. It's at 1.3414 something, so that's good. So let's try to run it. Cranking. Okay, started it right away. A bit of a drop. Right, let's try to rev it up a couple times. We heard it before with the old sensor. There was a lot of hesitation when you snap it, so let's try to look at it right now. All right. course, check engine light still there. We still need to clear it after. Alright, but I think we're pretty much good on this one with a new sensor. I'm gonna stop the capture for now. Let's try to take away the code, clear the code. So key on. Okay, do that again. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, see the check engine light go away. That means it cleared the code. Let's try to crank this now. Okay, so code is gone. Alright, because the key on, you already seen the right pressure. Alright, so right now we can call this one a fix.